Here is our best section of the entire semester. If you haven't been feeling very smart, this section is going to remind you of just how smart you are for taking calculus. We're going to do some higher order derivatives. When differentiation of a function goes beyond the first derivative, called f prime of x, the result is called a higher order derivative. To find a higher order derivative, it's also called a multiple derivative. All we're going to do is keep taking the derivative of a derivative. If you can take a first derivative, you can take a 20th derivative if you want to. Pretty much the hardest thing about this is just remembering to label your functions. So if our function is f of x, our first derivative, like we've been taking, we've called it f prime. Now we're going to go beyond that and we want to remember to label it. F double prime of x would be a second derivative. F triple prime of x would mean the third derivative, and then after that it just becomes too cumbersome to write those primes. So we normally would do the number of the derivative up in superscript. So f2, and if it had a 7 inside those parentheses, we would take the 7th derivative. And same thing if we started with a y, first derivative we call it a y prime, second derivative y double prime, y triple prime, and then after that we would write it as a little number in parentheses. There is another way to write a derivative. I usually don't use this, but we are going to get to the point where we do implicit differentiation in a few sections, and I will use it then just because it's hard to tell a y from a y prime, so I use a different way of writing the derivative. And we've seen it, but not for a while. It's dy dx. That means take the derivative of y with respect to x. And we could do that more than once. D squared y over dx squared means take the derivative of y twice with respect to x twice. Third derivative would be d cubed y over dx cubed. Take the third derivative of y with respect to x 3 times, and we would do that with any number. D to the n of y over dx to the n. And we will save this really for implicit differentiation. We're not going to use it too much now. And we're going to get to a point where we do some real life higher order derivatives. So I'll give you a preview of that right now. When we talk about functions in real life, we measure their position. So a position function seems like it would be a p, but of course math is hard. It's s of t. We call position s of t. Tell me the time and I can tell you the position. And if you take the derivative of a position, you get the velocity. This one makes more sense. It's v of t. Take that first derivative of s and you get velocity. And if you take the second derivative of s, you get acceleration. We only have 3 functions to put here, so I'm going to kind of ignore the table lines for a second. Acceleration is called a of t. You can find that by taking the first derivative of velocity, or it's the second derivative of position. Let's back up a second. Position has a first derivative of velocity. A second derivative of position would then be acceleration. And we'll get to that when we get to some real life problems. All right, so let's do some higher order derivatives. I swear you're going to feel super smart. It's not that complicated. The hardest thing is to remember to label your function. Beyonce's original lyric, if you like it, then you should put a label on it. So when we take our 6th derivative, we're going to label each function. I'm going to actually label it first just so I don't lose any silly points. I want to find the 6th derivative. So I'm going to find y prime. The derivative of y prime is going to be labeled y double prime. We'll find y triple prime. 4th derivative, we start using a 4. And then 5th, we put a 5 up in parentheses. And then lastly, a 6. So one thing you could do is if you feel like you're going to forget to label it, is label them at first. You don't have to use this method, but I will just because it's our first time and we might just forget to label our functions. All right, so my first derivative, as usual, I'm going to take the derivative of x to the 7th. So bring down the power, I have 7x to the 6th. Next one, bring down my power, 6 times 2 is going to give me 12x to the 5th. Next, bring down 2 times 3 is 6x. And then lastly, derivative of negative 4x is negative 4. There, I took my first derivative, something we're used to. Let's switch now, and we're going to do the second derivative. And there's really nothing to switch besides our label. Instead of calling it y prime, we're doing y double prime. So I'm going to take the derivative of a derivative, just like this box says here. To find a higher order derivative, take a derivative of a derivative. So I'm looking here. I'm going to bring down the power. 7 times 6 is 42, x to the 5th. Bring down the power, 12 times 5 is 60, x to the 4th. Derivative of 6x is 6. Derivative of negative 4 is 0. We just took our first higher order derivative. Let's do it again by taking the third derivative. Third derivative means take the derivative of the second derivative. So again, I'm going to bring down the power. 42 times 5, you might need to grab your calculator if you need to. It's 210. X to the 4th. Then 60 times 4 is going to be 240. X to the 3rd. Derivative of 6 is 0. So these derivatives are actually getting a little bit simpler because we're losing a term again. And its derivative is 0, so at least the answer is getting shorter and shorter. Next one, the fourth derivative, bring down the power. 240 times 4 is 840. X cubed. Again, you can always grab your calculator if you need to. 240 times 3, though, is 720. X squared. Bring down the power, subtract 1 from the new power. We just took a fourth derivative. Pretty crazy. Usually I have the homework stop at the third derivative just because it gets redundant, but I'm just going to show you, hey, here's the sixth derivative. Will I normally ask for the sixth derivative? Probably not. Just showing you that you can do it. Next one, fifth derivative, 840 times 3 is 2520, x squared. And I need to do 720 times 2 when I bring down the power, which is going to give me 1440x. Lastly, I'm asked for the sixth derivative, so once I find this, I get to stop. I'm running out of colors here. So I'm going to do 2520 times 2, which is 5040. X, and then the derivative of 1440x is 1440. So it took me a while, but it wasn't too difficult. Take the derivative of a derivative. Once you can take a first derivative, you can take any derivative that you want to. Okay, so maybe pause the video and try the next one if you want to. I'm going to work on it here. I'm taking the derivative of 5x squared plus 8x plus 32, and you could probably find this on your own. I'm going to find the fifth derivative. I'm pretty good about labeling, so I'm not going to label them ahead of time, but you can definitely use that method if you like it. Derivative of 5x squared is 10x. Derivative of 8x is 8. Derivative of 32 is 0. There's my first derivative. A little hard to read. Let me move that 10 over. So I have 10x plus 8. My second derivative, f double prime, derivative of 10x is 10. Derivative of 8 is 0. Now I'm ready to find my third derivative. Well, the derivative of 10, that's a constant. The third derivative is 0. And now it's going to be harder to label it than it is to find the derivative. Here's my fourth derivative. I'm not quite done yet. The derivative of 0. 0 is a constant, so it has a derivative of 0. I told you sometimes they're harder to label than they are to find. Last derivative I have to do though, and it seems silly, but yes, you do have to show all your derivatives, even if they end up being simple like this. The derivative of 0 is 0. It's my fifth derivative. That's what I was asked for, so now I know I'm allowed to stop. Okay. Next one, we have something a bit more interesting at least. We have the derivative of 1 over 4x squared plus e to the 3x. Something I noticed here is that I have a rule 6. I'll go up just in case you still needed to take notes on the other one. We have a rule 6. That's the derivative of the power times e to the original power. I have e to something besides a regular x. It's an e to the 3x. Oops. So I'm going to use the derivative of the power times e to the original power. And I'm asked to find the third derivative. So I actually am going to take a step and rewrite this whole thing because I have a fraction here and I don't have x's in the top and the bottom, so I'm not going to use a quotient rule. All I'm going to do is rewrite this as 4x to the negative 2 plus e to the 3x. I'll be super careful. That is not the first derivative. All that is the original function. And what's wrong with that? This is not how we rewrite a fraction. The x is 2 and negative 2, but I want to be super careful and just remind you of this algebra. You can't bring up that 4. You can bring up x to negative 2, but you can't bring up 4. So when you rewrite, be super careful on the homework because most of the time it's not the derivative at all, it's the algebra. I'm going to keep the 1/4 and all I can bring up is x to the negative 2. So I'm just showing you a common mistake. If you fell for it, that's okay. We're not going to fall for it when we do the homework, but I just want to show you that here. Now I'm really ready. I'm going to keep the 1/4 and I just brought up x to the negative 2. That way I don't have to use the quotient rule. So when you rewrite your algebra, just be super careful. Now I'm ready to do the calculus. I'm going to bring down the power, subtract them from the new power. You can grab your calculator if you need to. 1/4 times negative 2 is going to give me negative 2/4, which is negative 1/2. X to the negative 2 minus 1 is negative 3. Next one, I'm going to do the derivative of the power times e to the original power. So the derivative of 3x is 3, and then e to the 3x. There's my first derivative. Second derivative, I'm going to take the derivative of that. So I'm going to bring down the negative 3. And I could grab my calculator if I need to. Negative 1/2 times a negative 3 is going to be a positive 3/2. X to the negative 3 minus 1 is negative 4. And this one, I might do some side work. I'm going to hold on to the constant multiple 3 and do the derivative of the power times e to the original power. So derivative of 3x is 3, and then e to the original power. So it really becomes 3 times 3 is 9, e to the 3x. I kept the 3 because it was a constant multiple to the derivative of the power 3x, which is 3, and then I had e to the 3x at the end. Derivative of the power times e to the original power, and I also had a constant multiple to keep, which is why I did it as side work. Here is my third and final derivative. This is a really tough one, just because algebra is tough and then rule 6 is tough, so if you can do this, you are in very good shape. Let's bring down our power. 3/2 times negative 4. Well, I'm going to have negative 12 when I do 3 times negative 4. Negative 12 divided by 2 is going to give me 6. Or grab your calculator. X to the negative 4 minus 1 is negative 5. So I have negative 6. X to the negative 5th. Plus, and again, I can do some side work here. I'm going to keep my constant multiple 9. Take the derivative of the power. Derivative of 3x is 3. And e to the original power. So that's going to leave me with 9 times 3 is 27. E to the 3x. And there's my third and final derivative. So you can keep going, try the next page, and then I will post the video for you to try after. But you should be able to get at least the first derivative of the ones on the next.